Hello, today we are going to decompile Blazor Razor source code into C# source code. So this is a Blazor application, .NET 8 Visual Studio 2022. This is how a application created using the Visual Studio wizard looks like. This is the simplest type of Razor page possible. It just contains a route, a Blazor component, and then HTML. I've decompiled this to C#, and this is how it looks like. This add page slash becomes the attribute route slash on the class. There's a class that's generated from home.razor, which is this class home, inherits from component base, so from the Blazor base type. And then there's the important build render tree method, which uses a builder pattern in order to evaluate all of the lines in the Razor source code file from top to bottom in sequence. So very first thing that it encounters is this new line, doesn't do anything for it. The next new line doesn't do anything for it. And then it encounters the page title Blazor type tag, open tag. For this, it calls builder open component page title, and then for its sibling, for the close tag page title, adds this builder close component. The namespaces are the way we would expect. So by convention, we're inside of the Visual Studio project Great Blazor app. So that's the DLL that's being created. We're inside the Visual Studio solution folder components. So there's a Great Blazor app.components namespace. Then there's the pages Visual Studio solution folder, which is this namespace, Great Blazor app.components.pages. The name of the class is derived from the name of the Razor file, home.razor, and the class is home. Okay. So we've handled this part and this part. Next up, we need the text inside of the two tags, open and close for page title. That's done using a add attribute of type child content, which in this case is just adds the content text homepage. Then it closes the component. We're at this point. From here we have two new lines. So after the end tag of page title, there's this new line and a second new line. So these are converted to C# using builder add markup content and then two new Windows style new lines. So that would be a \r\n. The ASCII character 13 and then 10. Okay, then there's line 5 through the end of the Razor file, and that's added with add markup content, which has as a second parameter just a string. And it's just this text converted to string. So h1 hello world, h1, then one new line, then a second new line, then welcome to your new app, and then dot, and then a third new line. So first new line, second new line, and final new line. Okay, so that was the simplest possible Razor web page. Let's go to a more complicated one, the one with the counter, which uses render mode interactive server and contains a C# code block and has this Blazor on-click increment count event handler. Okay, let's see how everything is converted. We start with add page / counter. We already know is going to be a route attribute. The file is named counter.razor. The class is going to be named Razor. It's going to inherit from component base. The namespace is going to be greatblazor_app.components.pages, which we can see in here. Okay. Next up, let's go to render tree. We have a page title. Page title is handled similarly to the home.razor file, which is open component page title, close component, and then in the middle, it does a add attribute, child content, add content counter, which is the title of the page. Okay, this part is just HTML. So 2 new lines, then h1 counter, closed h1, new line, and then because P contains a bit of Blazor, this add current count, it's split down into bits. So the goes open element and close element, which is this part and this part. And then says there's an attribute role with a string value status, which is this thing. And then there's the part that's inside the start P and end P tags, which is a text current count and then a Blazor thing. So that's added as content. The plain text string is added as sequence 7, and then this C# part is added as is using the override for add content, which takes objects. The first one takes strings. So text content, the second parameter to add content of type string, and then add content, the second parameter of type object. Okay. Next up, button. Next up, 2 new lines. These two new lines. Okay. And then open element again contains Blazor. So you open the element button, you close the element, and then class btn primary is an attribute, similar to role status for the P. And another attribute on click. Okay. And inside, what does it put? Event callback factory create mouse event args object this increment count. Depending on the render mode, it's going to generate HTML in here, which is then used by the JavaScript machinery or the WebAssembly C# machinery that runs inside of the web browser in order to provide the advanced, enhanced event handling functionality. Okay, so in here there will be some I don't know, global unique IDs or some way to identify that special magic is happening. Okay, the content of the button HTML tag is the string click me. Okay, so we're at this position after the end of button. And now we have a C# code block which gets converted into all of the fields. So all of these declarations become fields in the class, counter in our case. So in here, private int current count equals 0. And then the method also gets added to the counter class, exactly as defined in here. So this is copy pasted as is from Blazor C# code block to the C# generated source code, and also this part. Okay, the last thing that remains is the line 2 in Blazor, which is render mode interactive server. Let's see what that does. So it creates a class, private component, render mode attribute, interactive server. And then that's used to put an attribute on the counter, on the current C# class. Okay. What else do we have? Weather has this placeholder while the page content is computing. This part, loading. Let's see how that is implemented. Let's edit the home page and see how we can have, as fast as possible, the Blazor source code reflected into C# source code. So Ctrl S, build the solution. And then reload in ilspy. Okay, so again, build, reload. Pretty fast. Under 3 seconds. Under 3 seconds. From the moment you change the Blazor source code to the moment you can see in ilspy the decompiled C# source code. Let's go back to the weather page. Okay, so in here we have this alternative where it's using stream rendering while the real content of the page gets loaded because of this task delay of half a second. We have the placeholder PEM loading with 3 dots. Let's see how that works. We start from the class, so the correct namespace, the correct class name, weather, the correct route attribute. And then we have this at attribute stream rendering. We can see it placed on the class weather. Then we go to the build render tree. And let's see what's in here. Should start from the page title. We've seen page title before, is this part. The result of this. Then there's new lines too. And then all of this part could be put in one go, but no. So weather, and then two new lines. This part, so lines 6 and 7. Then this component demonstrates showing data. This part. Then there's a C# source code block at if, which says if. So this is just copy pasted, this part. Okay. All of the HTML needs to be wrapped into builder.something, add markup content, add open element, close element. Okay, so it adds markup content, and then it does return. Okay, so this is a return early. This method build render tree is being executed. It returns early. And then it should remember that it returned early because forecasts is null. And then when forecast becomes non-null, this method needs to be invoked again by the Blazor machinery. And that is when it runs the second time, forecasts will not be null, the placeholder will not be shown, and the return early will not happen. And then the rest of the page is pretty straightforward. There is table class, table header, and table body. Then again a C# block at for each. There's a forecasts, which is what? Which is a private member of the class. These are copied above the build render tree method. And then this method is probably going to be below the build render tree method. Protected override async task on initialized async. Await task delay 500. Date only from datetime now. String array. And then some link queue, which could be, when decompiled, might land in SQL-like syntax or in this syntax with chained method calls. Of course, the result is the same. Okay. And then we have additionally this weather forecast class, which is this one. With public property getters and setters. And then a property with just a getter because it's computed from the other properties. Okay, who calls on initialized async? So this is probably a method that's defined on the base type on component 3. Whether on initialized async. Okay, and the Blazor machinery knows when to call this method. Okay, and then let's look at the for each. So we have data in an array of weather forecast objects. We're iterating through each of the elements in the array. We're doing tr, and then this is Blazor, so it's going to use open element both for the tr, which ends here, and for the td, which ends here. And then they pair close elements. So this is for the tr, and this is for the td. Okay, inside of the td we have exclusively C# source code, forecast, which is the loop variable, date to short date string. Okay, then it sees the \r\n once, this one, td, then C# source code forecast.temperature c, which is the prop getter, another new line in here, then start and end of td, inside C# forecast.temperature f. Okay, the same for forecast.summary. And it needs to close the opened elements, which is tbody and table. So two builder close elements, and they're opened in here for the tbody, this one. And the table is opened in here on sequence 7, this one. Okay, so after looking at a number of Blazor Razor files and the way it gets decompiled into C# source code, you kind of get to guess. So on the future, when you see Razor source code files, you have a sense of how it's going to be converted into C# source code. So when there's just free HTML with no C#, it's going to use add markup content. When inside of an HTML element pair, there's a bit of C#, then it's going to do open element and close element. And then it's forced to do bits by bit. So add each attribute. Okay, the same for instance, the forecast summary. So it needed to open the element td, close it, and inside it just has the overload with object or builder.add content, which just contains the C# expression. Okay. If you have code blocks with fields, those get put before the build render tree. If you have code blocks with methods and event handlers, these get copied after the build render tree method. Of course, the order in which the ilspy decompiler decompiles is up to ilspy. And the class, which is declared inside of the C# code block, this private class weather forecast is put inside of the C# class weather. So it's a embedded class. Okay. If structures which are part of the stream rendering use return early, repetitive structures should have the variable on which it iterates pre-computed, which it is because this is a private member which is computed on initialized async. Okay, and the C# for each block words inside of Blazor Razor file just get copied. The parts that are pure C# until it hits a less than character, which might be either valid HTML or Blazor component, such as this one, or a combination of HTML and Blazor inside. Okay, now let's see how we got here, how we created the Visual Studio project and solution, and how we can use ilspy. So for Visual Studio, I'm using Visual Studio 2022 Community Edition. This is gratis to use in my case, because I'm not using it commercially. I have installed C# and ASP.NET, so the web payloads. And then I'm creating the Visual Studio solution using the wizard. So I go create a new project. I have created a directory where I'm going to put the solution. You can search for Blazor, and it's Blazor web app. Next, Ctrl V. Next, I'm using the latest version of .NET, which is 8.0. I'm keeping the default values in here. What I'm not keeping is the checkbox for do not use top-level elements. So this is checked out by default. And I like to see top-level statements. So the class program and the method main for C# console applications. So I'm checking this checkbox. Great. Okay, let's close this tab. And now we can compile the solution. So rebuild the solution. Okay, and the end result, this is the directory of the solution. This is the directory of the project, new Blazor app CS proj. In there we have the bin directory. We're using the Visual Studio configuration, build configuration debug. And then we're using .NET 8. And this is the DLL that we're interested in. So the new Blazor app.dll, which was created by building new Blazor app.cs proj. Let's now look at the decompiler. I'm using ilspy because it's gratis and it's open source and it's great. Let's go to releases. in assets, I'm searching for not source code, but binary compiled. And I'm not searching for an MSI or exe installer. I'm searching for a zip or a 7-zip or an archive. Okay, let's see. So there's an installer MSI. No, not this one. There's binaries with 3 megabytes, and then there's self-contained 69 megabytes. So this one probably also contains the .NET Framework DLLs, and this one probably does not. So I'm not exactly sure how I would make this one work. Maybe it's built using .NET 8, maybe it's built using .NET 6, and maybe I do not have .NET 6 installed and I do not want to install it. So the sure way to go is to download the largest file from here, which is the ilspy self-contained 64 zip. I'm going to put it into the same directory where I always put important development tools. It finished downloading. Is this one preview to extract? I have a 7-zip installed, or you can use the Windows File Explorer built-in tool, which is extract all. Hopefully it works. If not, 7-zip always works. So it extracts many first-party DLLs, which are part of a .NET version. Okay, so this preview 2 is what we're after, and there's just 2 executables in here. You can sort by extension and go at .exe extension. And this one is the graphical user interface app ilspy.exe. Or you can just search by IL. You press IL, it's going to go in this area with ilspy dot something or ilspy.ell. Okay. Let's see how we do it. So we've built the new Blazor app. We're going to remove all of the assemblies that exist in ilspy. I'm collapsing everything in the assemblies tool view. Select all of the assemblies and then press the del key. Then I'm finding the new Blazor app DLL, this guy, not the exe. The exe is not actually managed C# or .NET. It's actually C++, Windows native. This one is managed and .NET. It uses .NET probably 8, which is the version that I have installed. Yeah, it's I've compiled it myself using Visual Studio. Okay, and then let's go to the same place. Components, pages, home. New Blazor app.components.pages is the namespace, and then home is the class. Expand everything. Increase the size of the fonts with Control mouse wheel. Control S, F7, and F5. And here is the change. Under 3 seconds to go from Blazor Razor source code to C# source code. The C# source code is actually decompiled. So the way it works is that this source code file home.razor is converted by the build machinery inside of MS Build, inside of the Visual Studio, into C#. Then that gets compiled to the new Blazor app.dll, which contains IL, so this thing. And then the intermediate language IL source code is taken by the decompiler tool ilspy from the new Blazor app DLL and converted to the programming language that you want. Previously, there used to also be Visual Basic inside of this combo box. Now there's only C#, IL with C#, but we're sticking with C# because that's more humanly readable. And then you can select the version of C#. For instance, you can go with the first version. That's the newest C# version that's supported by the first version of Visual Studio 2019, which is a C# 8. And that's it. That's how you can go from Blazor Razor source code to C# source code. It's not the C# source code, the C# source code that's generated by the Blazor build machinery. No, it's one that we decompile from the generated DLL using ilspy C# decompiler tool. Thank you.